GM everyone, and welcome back to Finality, where we explore the business and economics of decentralized networks. If you have been following our journey from Friends Validator, you know we have been deep in the trenches of staking, validation, and infrastructure for the past couple of years. And now, under Finality, we are continuing that mission, but through a broader lens, the economics, incentives, and sustainability behind the systems that secure crypto networks. And today I have the pleasure of welcoming Mathieu from Linera to the show. We will talk about microchains, Linera's economic model, AI agents, and much, much more. So with that being said, thanks for coming on, Mathieu. Good to have you.
Hey, everybody. Good to be here. Juri, thanks for having me.
Yeah, the pleasure is mine. And I believe before we dive straight into it, I did my homeworks prior to this conversation. So I believe it would be very interesting for the audience to learn a little bit more about your background coming from Meta and then finally entering the blockchain space. So maybe you could provide a super quick
For
background.
sure. For sure. Yeah. So basically, I have a background in I would say, classic infrastructure engineering. I was a software. I was a software engineering at Facebook. Started working on security infrastructure projects, then developer tools, and then machine learning infrastructure for a couple of years. And that's where I was approached, and I had this opportunity to join the Libra project of Facebook. So we were just they were just getting started with this ambitious blockchain project. And it was really, really interesting. And I have a background in security protocols from back then, from my PhD, and so it really felt like going back to work on science, and in particular specific protocols, or in this case blockchain protocols. But that was close enough. So I was immediately really passionate. Really interesting, and got more and more passionate about the field, this ability to create trust on the internet, out of kind of thin air, just algorithms basically, was and good tokenomics. That's really what interested me when and so we started working on the Libra project. I was working on the core protocol for a while. And then I started doing some research, and because basically we're starting to be a little worried at some point, what happens if we get 1 billion users suddenly doing payments, cross-border payments all over the world at the same time. The blockchain protocols at the time, they were not able to do that, and in fact still now, if you except for Linera, which I'm going to talk about in a minute, but very few people, like most blockchain protocols, they have a limit. So if you have the entire internet wanting to send transactions there, that could be a problem. So with my colleagues, we designed highly scalable, like a sort of infinitely scalable payment system back then that was called FastPay. And believe it or not, this research basically is the foundation of Linera and a little bit of Sui. And so Linera is a sort of a generalization, added smart contracts to that research project, and turning the whole thing into this new layer one.
Amazing. Yeah, let's dive deeper here, because at its core, you introduce microchains. And the name kind of suggests it already, what the term is all about. So you have like your main blockchain network, which is Linera, and then around that you have these microchains popping out left and right. So my question is, maybe to set the tone for the rest of the conversation, is how do you view microchains in the broader shared security space? Because we have seen similar concepts architecturally already with Polkadot. We have seen Cosmos. We have seen the L2 space. So for the people who say, okay, microchains is just another word for something that the other architectures are also doing. So yeah, what are microchains essentially all about? How do they differentiate themselves from other shared security concepts?
Okay, yeah, and so when you say shared security, it's actually a pretty narrow concept. Some of the examples you were saying, I think I would call them more like sharding, like sharded blockchains or exploring blockchain sharding. Historically, people have been looking into definitely trying to scale out blockchains by having several copies of the blockchain, basically. So we have the subnets in Avalanche, we have parachains in Polkadot, and then the Cosmos chains with IBC, Near also, and I think that's, yeah. I mean, so this is what comes to my mind right now. But there might be more. What people were looking in the initial wave of sharded blockchains, they were looking at keeping the nodes the same size, because the idea was like we wanted like lots of nodes, and if you need to scale out, then you recruit more nodes in the network. So that was usually the idea, where you I mean the different shards, the different subchains of your system would not have the same validators, because you would like to be able to recruit new validators and keep the validators relatively small. So that was typically the meta or the alpha at the time, and so what we're doing is completely different, because what we're saying is we're gonna have only one set of validators for all the subchains. So all the subchains are going to share the same security. So that's indeed a shared security system, where all the chains have the same set of validators. They have the same notion of finality. They have the same liquidity also, and that's really different. And so suddenly you find yourself having large validators. In the case of Linera, we are designing them so that they can be elastic, so they can grow in size over time, and also actually downsize if needed, to always be able to take the load coming from the network. Other shared security projects. So with that definition in mind, and so I guess the difference between shared and sharded, which can be confusing. But with that in mind, the systems with one set of validators and a lot of parallel chains are not that frequent. I have a few on my mind, and the difference with Linera is that I'd like to believe that we went all the way, and in particular, we are the only ones that give a chain to each user. So, and that's really an important concept of Linera. That's really what enabling horizontal scaling, and that's also something that would not be natural if you don't have this payment system that I was mentioning in mind at the beginning, like this FastPay paper. This is where really you see the ancestry of it. So the idea that you would give a chain to each user, and in that chain users would store their assets, is really what makes Linera different.
Yeah, let's talk a little bit about the small details. So you were diving deeper into the shared security concept. So and also mentioning that there's only one validator set, and you use the analogy earlier in the conversations that there are copies of the main chain, if that makes sense. So would you basically say that microchains are essentially small copies of Linera, and everyone settles on the main chain with the core validator set of Linera? This is how it works in a high level?
No, but it could, yeah. So that's how people would design sharded systems, I would say, in the past. Typically, you would have a number of subchains, and sometimes you would have to kind of bubble up the transactions and settle them at the high level. And that's a very natural idea that I'd say would come from the banking system. Like the top chains would act as like a CBDC or something like that, as a central bank. But so what we do in Linera that is very different, actually. What we're saying is that because the chains, they live in the same validators, and they are validated in the same way with the same rules, they're in fact running even the same applications. There's no every block that we create in Linera is equally final. There's no need to resettle the block anywhere. So every block is equally final, and that's really important for payment applications and many other kinds of applications. But for payment, for instance, so the way it works is I have my chain. It's a tiny chain that only has like small blocks that I create only when I want to do something. And it holds a tiny ledger that has my assets. Now, when I want to move, to transfer an asset to you, what my Linera client that's running locally has a copy of the chain is going to come up with a new block. So propose a new block that I'm going to sign, that contains an operation that says, hey, you need to transfer this asset to this person. And then when you execute the block, it's going to burn the asset from my chain and then send an asynchronous message to your chain that says, hey, you have some assets, you can mint them now. And so it looks like a payment in Linera looks like a little bit like a one-way bridge, if you're familiar, except both ends are running the same code and are living in the same validators, which simplifies things a lot. Because now when I see a message that tells me, when I'm from the point of view of a receiving chain, there's a message coming in that says, hey, you can mint some assets. I can trust that message, because this message actually comes from a block that is certified by the same validator as me, and in fact, the message has been created by the same code that is going to receive it. So you have the invariant that if I receive a message that tells me to mint some assets, you can be confident that they've been burned on the sender side. So that's this way the assets are worth something, like they were actually burnt from the other end. So we're not minting assets. We have a global invariant, as you would expect, that the assets can only be moved around and not created out of thin air. But yeah, and so interestingly, I think if you look at this payment system where assets move directly from one user chain to another user chain with these asynchronous messages, you can see that there's no bottleneck in the system. Like there's not a single chain of block that would create contention between the users. In this case, right? In this for this category of applications that only use user chains on here, and it's a new category. So it's a new way to program certainly a payment application, but in the case of Linera, we also have we apply similar ideas to many more applications to make them horizontally scalable or more scalable, when otherwise they would have to live on a single chain of blocks and just like hope that there's no contention when they run.
Interesting. So, but just to clarify once again, so due to this bridging technology, I would say, in terms of settling.
Yeah, it's internal, it's messages. Yeah, question messages, we call them. Mm-hmm.
Okay, it's a question messaging technology, and essentially the validators who run and validate Linera are automatically also validating these microchains, or can they also pick, for example, could they say, okay, there's like a microchain that we do not want to engage with at all, or is everything automatically handled?
Yeah, so creating a microchain is basically you span. So it's like creating a thread of execution. If you are familiar in the programming language, so you just execute an instruction that's going to create a new thread of execution. So similarly in Linera, you execute an instruction that's going to create a new microchain.
Yeah, that makes sense. So let's talk a little bit about why microchains are such a hot topic right now. And you already indicated something at the very beginning of the episode with regards to micropayments, which is like something that is super relevant for AI agents. And in a video that I've seen on X from you introducing the new testnet, you stress the importance of microchains in the age of AI agents. So could you walk us through that? So why could microchains be so relevant in an era where AI agents become more and more important, and what does that have to do with micropayments?
Okay, yeah, and we sing, by the way, with the standard X42 that has been announced. I mean, some standardization that has been announced in the previous weeks by big actors that micropayments are coming. Crypto micropayments are coming, and in particular, the use case that everybody has in mind is the e-commerce using AI agents. So the idea is you would have everybody will have an AI agent running on their computer, and that can execute high level tasks. You want to book an entire trip, the AI agent will go over the internet and gather the information, and once you approve, we'll start booking the flights, booking the hotel, and the restaurants, and so that's like a really exciting time, to see that happening, like a real shift of paradigm in the way we consume applications. So we're going to use the keyboard and the mouse concretely, less and less, right? Less and less often. And it's going to look more and more like in the movies, where you talk to a computer and you express high level intention, like high level orders or commands and or desires, and the AI agent tries to come up with a plan and then execute the plan. But now, and so in this picture, blockchains have a role to play, a very big role to play, because obviously we have created those programmable ledgers, those new financial APIs that not only run on the internet and are decentralized and very secure, but they're also programmable, and they are easy to handle for other programs, for agents. But there's a catch. The catch is, how do you actually interact with the blockchains? And so when you are a normal user of a blockchain system, it's more likely that you don't have a full node running on your laptop, on your computer, or on your mobile. Like for those who don't know, so a full node is basically the idea is that you may not be a validator in a system, but you're essentially participating to the blockchain network as much as a validator. You are copying that having a full node, maintaining a full node requires very strong connectivity nowadays. With modern blockchains, you're going to have lots of blocks to download, lots of transactions to execute. So it's requiring like really beefy machine. It's and sometimes that's even like requiring maintenance, and it's kind of a matter for professionals to run a full node nowadays for the modern blockchains. And it's getting more and more difficult. So basically, nobody is running full nodes. Nobody's running. So what it means that nobody has a copy of the blockchain locally. So now, when you want to read data from a blockchain, or when you want to send transactions to create to do something, because you're not part of the blockchain network, you don't have a full node. What you do is you talk to somebody who has a full node, and it's called an RPC provider. So a provider for specific kinds of APIs that allows you to call into the blockchain. RPC providers are sometimes managed by the foundation of a blockchain, but they're always centralized. Those are like essentially centralized, like classic Web 2 pieces of infrastructure that are exposing APIs based on the full node that they're running, and possibly some indexer logic and so on and so forth. So okay, so what it means that currently every user of a blockchain network, when they run a front end, the first thing the front end does is calling a centralized entity. And it's a bit disappointing because we thought blockchains were super decentralized, and now we introduce single point of failures, we introduce intermediates that could maybe sometimes get hacked. For humans, people have got used to it, but now when you replace front ends by AI agents, it gets really much worse, because now you have an AI agent that's going to make automated decision based on what they read from the blockchain, financial decisions, that can. And so you really would like to know that what they read from the blockchain is accurate. You also would like to know that the information is not hacked and contains. There's this thing called prompt injections that can be very dangerous for a certain category of AI agents based on LLMs. So LLMs is the the new family of models that is used in ChatGPT, Claude, and Gemini. It's like really the state of the art of AI. Not that you necessarily need that for financial training, but we're thinking that the AI assistants of the future are all going to use LLMs. Unfortunately, LLMs they don't really make any difference between data and code, or data and instructions. So when every time you connect that's something to know, by the way, in general, every time you connect an LLM to an external service, you're taking a little bit of risk that the service could try to inject prompts, like malicious prompts, in the middle of the data that they were supposed to return. So when that happens, what it looks like is essentially you send a request to the server, you say, hey, I'd like to know the balance of my account on the blockchain. And what you get is a JSON file. So you get this text file that's supposed to be well formatted, but except in the middle, there's a sentence that says like, oh, forget about JSON. Actually, I have something to tell you that is more important. So please, can you do this and that? And sometimes the LLMs turns out they look at this and they forget whatever they were doing and they start executing the prompt, which in the case of a financial agent could mean like you start buying stuff on the internet that you don't need. And that's a problem. So now how do you actually connect AI agents to blockchain securely? Ideally, we'd have a full node, but the next best thing, but that's not possible. So the next best thing is to have what's called a sparse node. So you replicate the data of the blockchain locally, and then you run your own service locally that the agent can query, but it's only a fraction of the data. But that's kind of hard to do in a blockchain that is monolithic, where all the data, all the transactions are running on the same blockchain. But turns out Linera is not a monolithic blockchain. Linera is made of millions of parallel chains, potentially. Each of them is mostly independent, and as a user, your data, more often than not, are on a specific chain. And so that's the one chain that you definitely want to replicate locally and expose to your AI agent. And that's what we do. So in Linera, you connect your agents to you have a user chain that contains your assets that is kind of acting as a gateway for the entire system. And that's a very natural place to connect an AI agent, a very secure way to connect an AI agent. That's gonna let your AI agent talk to the Linera applications locally without any network traffic. So you're not also another advantage of that is you're not leaking your intentions. The AI agent is not leaking what you're trying to do before you actually do it. That could be important for financial trades. So the privacy, and then once again, the AI agent is talking to a local service that is running locally. It's actually executing code that is in a VM, so it's immutable. It's been reviewed, audited. It's really just the most secure way to connect an AI agent to blockchain, and that's why we built on Linera.
Amazing, and yeah, thank you so much for the in-depth explanation on all of that. Just to clarify it and to make it as crisp as possible, I would say. So, how do you? So how would the world for you in the future will look like, considering all of what you have just mentioned with regards to how each AI agent will work? So would that mean that each AI agent would maintain its own microchain, or will there be specific ones, or will each application has its own
Possibly.
microchain?
Well, possibly, or you can just your own, as a user, your own microchain. You can just connect the agent to it, the agent to it. That would be the same thing as like giving access to your bank account to the agent, if that's what you wanted to do.
Okay, so for instance, my online banking or my American Express
Okay, I said bank.
own.
I said bank. I meant crypto wallet. Yes.
Yeah,
Yes.
but
This way, not so
theoretically, like talking like from like, let's say, okay, the world in 10, 15 years from now, people still are using banking applications. So for example, banking applications from your local bank could be one microchain, and you allow an AI agent to interact with that. So they're like certain
Yeah, you
single
would
point
have
of
all
truths, right?
right. So you would have all the, it's like your phone. You would have all the applications of the different financial institutions that you talk to on the same chain, on your chain. so that they can compose to with each other, by the way. And that's that one chain, your personal chain, that's where you would typically connect an AI agent to. Yeah. Mm-hmm.
Amazing. Which leads us to another question with regards to scaling. So there have been, for example, projects like, I don't know if you know it, but Orchid. They focus a lot of on micropayments. So in order to make an AI agent work, he needs to be incentivized financially, specifically through micropayments. And these payments are also now for the audience, not payments like 1 cent, 2 cents, but like payments that are less than 1 cent. So can you elaborate a little bit more on how to handle micropayments on Linera?
Yeah, and well, that's basically what I was explaining a bit earlier. So once you have your assets on your own tiny microchain as a user, every micropayment is just you creating a tiny block, which is instant because there's no contention with other users. You're already just creating a new block in your reserved block space. So you can do that as often as you want. And that only takes 200 milliseconds currently on the testnet. We think that we can go, in fact, way below that using a number of ideas, one of them being what we call geographic sharding. So the idea would be to have your microchain in the same region as you of the internet, or perhaps even in the same city, so that the connectivity is minimized. The latency, the network latency is minimized. And so the vision here is that really creating, initiating a payment in Linera would be, I mean, definitely like really, I mean, would feel instantaneous, right? And so can happen under the hood if it's managed by an AI agent while you're browsing websites with the X402 standard that everybody's talking about. That's the vision, right? You're browsing a website, and an AI agent knows your kind of your spending policies, and is going to do micropayments for the content that you're consuming, with that being completely out of your way and definitely not slowing down your consumption of the content. And so the nice thing about Linera is really once again that you can create those micropayments anytime with guaranteed latency, because you're acting in your own reserved block space, your own chain of blocks. And that takes, so currently 200 milliseconds, so it's very slow, very, very fast. And and then the nice thing also is once you've started the payment, you can take a receipt and you can show it directly to the website. So the settlement time is also is essentially instantaneous, because you can prove to the website right away that the money is in flight, the money is arriving. Something that is actually difficult to do in other blockchains that don't have this setup, and I guess this history of being based on a payment system.
Amazing. Yeah, thanks for the clarification. I think that was like super useful. And now that we have understood what the system is all about, so how it works architecturally, where you expect a lot of demand coming from, which is AI agents, as mentioned, which will obviously play a huge role in the future of humanity, I guess. I think that's not a hot thesis anymore when saying that. Let's talk a little bit about the economics, because you are also running on POS, and it's very important for POS system to generate enough revenue in order to pay for validators. And I had a very interesting conversation with Celestia last week about how shocking it is with regards to the pricing of bringing a blockchain to life and keep it run. So there are a lot of participants, like the more decentralized your chain is, the more expensive it usually is to run the chain. So can you first talk on how fee generation is happening on Linera, like where basically the fee generation and the money comes from, which currency it's generated in, and then also the entire dynamic, obviously, with the microchains here. Are microchains paying the validators with additional incentives. So how does that work precisely? And what if they are like individual microchains who have low activity or no activity at all?
Okay. Yeah. Also, okay. So I see where you're coming from. So an important point to clarify is that, and that's one of the advantages of this design with the microchain, is that when you are not using your validators of Linera don't actually really need to know about microchains. They don't see them. It's like it's basically they are hidden in the middle of the block space. It's just a different way to structure block space, but it's from the point of view of the validators, they see a traditional proof of stake system. And when people create blocks in their chain, there's a fee. We compute the fees based on the fuel consumed in the block and a number of other parameters. That formula tends to be we like it to be fixed and predictable, at least for a given period of time. People know exactly what the block is going to cost, and the price is the same disregarding which microchain you're using. What else can I say? And so once again, when you are not using your microchain, you're not paying fees anymore. That's fair, but it's also not doing anything anymore and not costing anything anymore to the validator. It's basically sleeping in storage, which is very important definitely for the economical health of the system. We would like, the opposite would be a problem. So, and that's definitely also a difference between, you were asking about previous sharding concepts in blockchain. When you, in traditional subchains, once you create this subchain or this parachain, it has to keep running, even if nobody's using it, basically. So we don't have this problem with microchains. Overall, Linera has to have enough users to pay to create fees to essentially increase the value of the token so that it compensates the tokens that you mint to the yield that you give to the stakeholders as a reward for staking in the proof of stake system.
That's super interesting. Yeah, that's actually a novel concept. But let's also take one step back. I think this is like very interesting, the dynamic with the microchains here. But how does it work on the main chain itself? So, because this is like something that a lot of chains had issues with in a shared security model, is that
Right.
the main chain, so in your case, Linera, is launching, and we've seen it in Cosmos, for example. They launched the chain itself, then there was not much going on. People basically secured the chain. Interchain security, which was their shared security system, wasn't even live. And when interchain security was live, it also took some time before Neutron, Stride, and other chains, in your case microchains, launched. And until then, there was no native feed generation, and validators were just paid with inflation. So how do you try to overbridge this period?
I mean, the system is I would say the system is completely different. We don't have a main chain, so there's only one set of validators to finance, right? And anytime you use any of the microchains of Linera, which is all there is in Linera, by the way. Linera is only made of microchains. So anytime you use a microchain of Linera, that's generate fees that goes to all validators of Linera according to the uniform formula of the proof of stake system. So there's no, so we don't have the problem of, I would say, of sharded blockchains. We don't have the problem of this ecosystem of chains where, if I understand what you're saying, like some chains would be hotter than others, and so the fees would be kind of unfairly distributed. So that construction cannot exist for us.
No. My question was more: usually you have like this, and I think that's like a general thing in proof of stake system, regardless of dealing with shared security models or applications.
Okay.
You launch a chain, and then it takes sometimes until the first applications or chains are built on top of it. In that period, the chain is already
Okay.
at mainnet, so validators need to be secured for basically supporting mainnet, right? So
Okay.
this is this crucial period of time where you need to.
Yes. Yeah, the new meta is that you launch mainnet with a number of exciting applications. That's the answer. Yes. Yes. You want to have exciting applications running, if possible, from day one on your mainnet. Mhm.
Okay, so to basically get around this chicken and egg problem. Got it. Yeah, maybe you can talk a little bit about the ecosystem's
Yeah,
growth
and that's
here. What are some
uh-huh.
applications you are excited about?
Yeah, for sure. That's a great question, because we talked about AI agents, and the question that people often ask is, okay, that's nice, but what kind of applications are your agents going to be using? And so first, the and just to continue on that topic. So first, every Linera applications will be compatible with AI agents by construction. So that's one of the things that is really nice in Linera. So every Linera application will be agentic by default. And so now, but now what kind of applications run on Linera? So whether that's for humans or for agents, we are very excited about. So I talked about payments. So X402 is cool, but in general, we are really excited about DeFi. We are really bullish on DeFi, and in particular on prediction markets. This is really the thing where we've been looking into recently. What's nice about prediction markets is you can completely see how microchain can help to scale, because there's this very simple idea that you run a one market per chain, and so if you have 100 markets, then you can use 100 chains, and you got this scaling factor for free, which is really cool and can really help scale out prediction markets, in particular making them more real time, more interactive, so more fun to play with, and more useful for people who want also to extract data from them. They can do that in real time. They can may even like subscribe to modifications to the price of a particular market at a given time. And that's not even the end of the story. We have more designs now, more potentially where you would have a hybrid system where the markets would be shared on several chains, while maintaining the settlement in parallel on many chains, as many chains as you need to make the whole thing horizontally scalable. So we're putting the microchains to good use on DeFi, and building some really exciting protocols that are going to be basically exceeding any blockchains out there in terms of maximum TPS and latency. One of these aspects, so perp dex is obviously interesting, boring landing, and prediction markets is really what we're looking into. And obviously AI agents are going to be very happy to work with the prediction markets, or conversely, we're going to be very happy to have AI agents work on prediction markets. We know that when you have lots of markets, some of them are correlated. There's this classic example of, you have like who's going to win this person is going to win the next election, or this party is going to win the next election, and the two things are basically the same. And so if you have many instances of markets that are heavily correlated like this, it becomes a bit tedious for humans to go and go over them. And so you'd like to have some form of automation that understands the text of the markets. So basically, you need an AI agent.
Amazing. Yeah, sounds super exciting. And I mean, obviously, prediction market is like a big hot meta. And yeah, interesting what you've said with the current understanding of the situation is that you need to have kind of an existing ecosystem already before going live, because otherwise there will be an uphill battle around the corner. But speaking about the future, you announced the latest testnet round recently. So yeah, maybe you can talk a little bit about where you guys are right now, heading towards the end of this interview. So yeah, what's up to come, what's next, and when mainnet, of course.
Okay. Yeah, for sure. And first, let's talk about what we just launched. We just launched a third testnet that is really raging. We created a portal to manage points that people can earn by doing a number of things. One of them is to play with an app that we just coded. That it's a puzzle app where you get to solve puzzles that are inspired by the game of life, which is a cellular automata. So it's a computer thing that was invented by John Conway, and basically we chose that because it's fun. If you are into computer science, like, for me, I was doing this. I was learning about this as a teenager, and that's kind of what got me into computer science. And what else can I say? It's game over, and the testnet is called Conway. That's the reason. So we just launched that. Got millions of transactions already out of this in a few weeks, and we're working on the next applications to be announced soon, running on a testnet, but possibly with also some points to earn. What else can I say? We have been improving the testnet quite a bit. The latency now back to 200 milliseconds per to finalize a block, which is kind of pretty awesome. And so stay in touch. And of course, almost forgot, we are running a buildathon right now. So there will be many waves across several weeks, and each wave will be attributing some prizes based on the submissions. So if you want to learn more about it, just check our website or our Twitter, and find us on Discord. Find all the details there, and we look forward to see what you guys are going to build.
Amazing. And do you also already have a timeline approaching mainnet? I believe that's also something that a lot of people are interested in. I know, I believe I'm not the first person to ask this, but I need to ask it.
Yes. It's getting closer. We're working really hard to make that happen. So probably not this year, but we'd like that to be relatively early next year.
Amazing. So maybe at the start of ETH Denver. Yeah, maybe you can provide a couple of social media contact points. So where should people reach out, have a look at when they want to dive deeper into the Linera ecosystem and want to learn more?
Yes, I guess the easiest one is the website linera.io, and then from there you can find all the rest.
Amazing. Super straightforward. Sounds good. Mathieu, thank you so much for coming on.
Yeah.
It was a pleasure. I feel way more educated about Linera. Also very interesting how you approach the economics with also microchains not having to have activity to be basically supported by the external validator set. And by launching an ecosystem already at mainnet and not encounter this chicken and egg problem that we have seen in the space more than often. So yeah, that was super interesting. So all of the best for the rest of the quarter, and best of luck for the upcoming mainnet.
Yeah, thanks for having me. Bye everybody. See you all.